Hey guys, this is Professor Janacek. I want to talk about how to find the volume of a solid. Now, if you remember, in a rectangular sense, area is length times width. Volume, again, in a rectangular sense, is length times width times height, but that length times width is the area, so it's actually area times height. Now, in this situation, I'll refer to that height as thickness, so our volume is area times thickness. That's going to be the main idea here. Volume is area times thickness. So, for this particular method, it's called the shell or cylinder method. The idea is that we're going to take a three-dimensional solid and we're going to look at it with layers. So it's going to be a cylinder within a cylinder within a cylinder. You could also think of these as shells, but it's really like layers of an onion. Peel away one shell or one cylinder and you have another shell or cylinder inside that, so on and so forth. We're just going to look at one of these cylinders, and that's going to give us our shape. To begin with, we can imagine that this particular cylinder is created by taking this little bit here and rotating it about our axis. In this case, we're going about the y-axis. So that's how we're going to build our cylinder. Also, if you take that cylinder and you cut it along that little black rectangle and unroll it, what you end up with is a rectangle. And that's going to be important for finding our area. So we have a rectangle. How do you find the area of a rectangle? Well, that's simply length times width. And we've already reminded ourselves that our volume is going to be the area times the thickness. So volume is area times thickness. Our area is length times width. So therefore, our volume is length times width times the thickness. Now, this thickness, though, this length, though, the length down here, that came from the circumference of our circle. So we can write this instead as the circumference times the width times the thickness. But how do we find circumference? Well, that's 2 pi times the radius. So our volume is 2 pi times the radius times the width times the thickness. And that's how we get our formula. Our formula is the volume is equal to the integral of 2 pi times our radius, but our radius here in this situation is an x value. So our radius is just the x value. And then our width is the difference between our two functions f of x, g of x. And then finally our thickness is our delta x, which is approximated by dx. So there's our formula. I don't recommend that you sit down and memorize it. Remember where it comes from. Remember that this is the length times the width times the thickness. And that this length is really the circumference, which is 2 pi r. Remember what that graph looks like. That r is the x value. So remember how to build it rather than memorizing the formula. I do want to point out we can also look at this situation where we're revolving about the x-axis, in which case we change our variable and we're looking at using y's. We integrate with respect to y in that case. Now, I know this is kind of complicated, so I have kind of a checklist I like to go through for this. If I am revolving about the y-axis, and my little piece that we've selected, our little rectangle, is actually parallel to the y-axis, then we're going to integrate with respect to x, and we will use that area is equal to length times width, or that length is 2 pi r times the width. Of course, if we are revolving about the x-axis and the piece we are looking at, here it is, that piece we're looking at about the y-axis, and our piece there is parallel to that. I'm sorry, we're revolving about the x-axis and the piece we're looking at is parallel to the x-axis. Then we will integrate with respect to y, and for our area, we'll again use length times width, which is 2 pi times the radius. Just remember what that radius looks like. Remember our little drawing, times the width. Again, I like to kind of use this as a checklist. If I have this and I have this, then I do this, and there's the formula that I'll be using. Okay. Again, try not to memorize those formulas, just remember how to get to it using that area. Enjoy!